For this video, we are going to verify an identity. I'm going to walk you through this one because this involves a lot of algebra and some trig identity stuff. But the first thing you want to do always is decide which side you're going to work, because you're not going to work both. We cannot assume that these are equal. That's what we're trying to prove. So we can't do things like I can't add 1 to both sides, because that's assuming that this is already true. And we don't know that. We're trying to verify that. So I'm going to leave the right-hand side alone because it is simpler. I'm going to work on the messier side and see what I can do with that. So the first thing I see when I look at the left-hand side is that I don't have a common denominator, and I'd like to. So I'm going to find a common denominator. To get that common denominator, I'm just going to multiply the two denominators I have together. So that would be cosine x times 1 plus sine x. So I'm going to now rewrite this with a common denominator. So I have cosine on top. On the bottom, I get this common denominator, which is cosine x times 1 plus sine x. I multiplied the bottom by cosine, so I have to also multiply the top by cosine. And then on the right side of this part, we're going to write that common denominator, cosine x, 1 plus sine x. What did I multiply by here? The 1 plus sine x. I already have 1 up here. I just multiply by another one to get that common denominator. So notice in this step, if I wanted to, I could cancel here, the 1 plus sine x is out. I could also cancel these cosines out. I don't want to do that. I just put those there so that I can use them, so you don't want to cancel. All right, now we are going to rewrite those. I can rewrite the top as, if I can get my pen going, I can rewrite the top as cosine squared x, cosine times cosine. And then this the right side over here, 1 plus sine x times 1 plus sine x is 1 plus sine x squared. And then on the bottom, I now have a common denominator, so I can write it all together, 1 plus sine x, cosine x times 1 plus sine x. Okay, so I'm going to FOIL on the top. I have cosine squared x. I'm going to FOIL this, so you can basically think back to this step up here and FOIL. So we have then, we're looking at 1, whoa, I don't want to do that. We have 1 times 1, that would be first, and then outer would be sine x, inner would be sine x, and last would be sine squared x. This is still all over that denominator, cosine x times 1 plus sine x. And then I'm going to work over here so I have a little more space. We have, if I rewrite this, we're looking at cosine squared x plus 1 plus 2 sine x plus sine squared x is over our denominator, which is cosine x times 1 plus sine x. And then I am going to rewrite this where I have cosine squared x plus sine squared x plus 1 plus 2 sine x over my denominator. This gets tedious to write all of this, but you have to keep track of everything that's going on. Now, this is the Pythagorean identity, that cosine squared x plus sine squared x is equal to 1. So I'm going to rewrite this then as 1 plus 1, right? The cosine squared x plus sine squared x became 1. Now rewrite the other one plus 2 sine x over my denominator, which is cosine x 1 plus sine x. Now, this is 2 plus 2 sine x over cosine x times 1 plus sine x. Rewrite again. I'm going to pull this 2 out on top. So I have 2 times 1 plus sine x over cosine x times 1 plus sine x. Now I can cancel these. I get 2 over cosine x, which is equal to 2 times secant of x, and I'm done. That's 2 times secant x because this is basically 2 times 1 over cosine. And remember, 1 over cosine is secant. So you're looking at 2 secant x. So we matched up this with what the right-hand side looked like at the beginning. So we finished that identity. The biggest piece of advice in verifying identities is to just try something and be really careful with your algebra.